Now we move to the fun stuff. And you know, when I say fun stuff, that's where it starts to get challenging. And we've looked at this a little bit already. So if you recall in the rules, it says that if you have a radical in the denominator, you have to get rid of it. Well, not always will it be a perfect square. So this is going to create a situation where we have to rationalize the denominator. Now, the idea of rationalizing the denominator is to multiply the expression by something equaling to 1. Okay, and when we do this, we're going to look for the bottom value in the denominator as a guide to what to multiply by. So if we look at this first example, we have 1 over the square root of 3. Well, since it's the square root of 3, we're going to actually want to use the square root of 3 because we know square root of 3 times square root of 3 is going to give us square root of 9, which is just going to be 3, and this allows us to clear out the radical. But because we're multiplying the bottom by the square root of 3, we also have to multiply the top by the square root of 3, and this gives us a fraction that is a form of the number 1. So what's happened here is the value does not change. This is important. We want the final answer to have the same value as the original problem. We just want it to conform to all of the rules of radicals. So square root of 3 over 3, if you were to put that in your calculator and get a decimal, should equal the same thing as 1 divided by the square root of 3, except now the form of our radical fits all the rules for simplifying radicals. So this is rationalizing the denominator. Now, in many cases, once you rationalize the denominator, you still have a little bit of work left to do. So if we look at set B, we've rationalized the denominator right here with the square root of 5 over the square root of 5, and then upon finishing this, we still have a 15 and a 5 in the fraction. Well, the radical square root of 5 kind of acts like a variable. You can reduce the 15 and the 5 without actually changing the radical, since it acts much like a variable does. So that can be reduced. 15 over 5 equals to 3. And so that is one example of something that will happen as well. Now, this last example is very important. Notice that when we had 4 times the square root of 2 in the denominator, we only needed to rationalize by the radical. It was unnecessary to include the whole number 4 to eliminate the radical. So you will run into some problems of this nature as well. So go ahead and take a time to do sample problem number 4. Pause the video and see if you can work those problems real quickly. Okay, so if you've done this, square root of 4 over square root of 5, we need to rationalize the denominator. If you want to go ahead and simplify the square root of 4, you're more than welcome to go ahead and do that process ahead of time. So if I multiply the square root of 5 over the square root of 5, I'm going to take the square root of 4, which I know to be 2, and go ahead and finish that. So now 2 times the square root of 5. This is kind of like multiplying 2 times x. So if I multiply 2 times x, I would simply get 2x. So 2 times the square root of 5 is simply 2 times the square root of 5. So they don't combine together because they're not like terms. So that's going to give me 2 times the square root of 5 over square root of 5 times square root of 5 is square root of 25, which we know is simply 5. So we've rationalized the denominator using the square root of 5 over the square root of 5. That's a form of 1, and that allows us to simplify this radical. Part B, 3 times square root of 2, so we would need to multiply this by the square root of 2 over square root of 2. So we've rationalized the denominator there. So that gives us 3 square roots of 2, and square root of 2 times square root of 2 is simply square root of 4, which is going to be 2. So whatever the two radicals are, it's going to eliminate the radical and just give us the whole number underneath there. Lastly, square root of 6 over square root of 15. Remember, from the quotient property, this breaks up. However, with the square root of 15 on the bottom, we have to rationalize the denominator. So I'm going to multiply this square root of 15 over square root of 15. And this creates a little bit of a different scenario here. What happens is 6 times 15 is actually going to give us the square root of 90 on top. We've eliminated the radical on bottom through rationalization, but we now have a situation where we can we have to simplify the radical 90. So this is going to break up into the square root of 9 times the square root of 10 all over 15, which is going to give us 3 square roots of 10 over 15. Again, this looks like we might be finished, but remember, the square root of 10 is kind of like a variable here. The 3 and the 15 can actually be reduced into 1/5, and of course the 1 is understood, so the final answer is the square root of 10 over 15. So that is a more involved problem, but a lot of the radicals that you're going to have to deal with are a little bit more complex, like part C is.